Duncan has recently physically joined us in the Central House and from the Intel Collaborative Research Institute, and we jumped at the chance to host Intel, given the previous work and the support that they give us with all our projects. And a few of you have also seen them up on the 4th floor and wonder what's going on, as well as in general the collaborative work we're doing. So we asked Duncan to come in, have a chat, and so he'll talk more about, hopefully, if I've got this right, a bit about the whole collaboration, and then a bit more about what Intel are doing specifically. Yeah. And there are some sort of drinks and nibbles on afterwards, just in case you want to have a chat and meet a few other people and that sort of thing. And so we'll just talk for however long you want, not too long.
Yeah, 20-30 minutes, that should be fine.
Great.
Okay,
thanks.
Thank you very much. Yeah, it was literally just taking the chance to just come and say hello and just introduce what we're doing. Thursday is a particularly busy day up on the 4th floor because we actually have there's a project that we're running at the moment, and the project meets in there. So if you come on a Thursday, it'll look like there's loads of people from Intel working. Actually, there's actually 3 of us up there, sort of on a day-to-day basis, but it goes up to about 12 or 15 on a Thursday. 20-30 minutes, just to give you an overview. My aim is to actually just tell you what we're doing. So if you do, just interrupt me and ask if anything doesn't make sense or you want to know more about it. I thought I'd try and cover kind of some of the context behind the city's work that we're doing, give you some ideas to why Intel are actually investing in this city's work, and that might not be a natural association that you might have made. And I'll just go through a couple of the projects that we're incubating at the moment, just to give an idea of the kinds of things that we're working on, but also to try and pose the question of how can you guys help get involved in some of those projects. So it's, I'm doing that not to show off what we're doing. It's more of a question to say, how can you guys help us on some of those projects? So just to give you some of the kind of context of where I've come from, I've spent the past 10-15 years working within the built environment. I used to work for OVE Arup originally, and this is one of the first projects that I worked on when I joined Arup back in 2000. If you're based in London, you might have been here when this bridge started to wobble. Was anyone here when it wobbled? Yeah, there's a couple of people. So we literally got the phone call to say about a week later, after the bridge had been closed. Sorry, the bridge closed because it wobbled. It moved from side to side, and it was closed because they thought it would be dangerous and people might fall off the edge of the bridge. But also, it was one of the things that the engineers didn't know why it had wobbled. So the R&D guys kind of sat down and went, why did this happen? It was a phenomenon that they weren't expecting to see. And so they did a massive amount of, so they had this idea, and I got the phone call 2 weeks into my job, and they said, we think we know why the bridge is wobbling. We need to measure every time somebody puts their foot on the floor, because we need to measure the forces of when people are walking. Because when people walk, if you're like a cowboy, you walk like this, you tend to push more out to the side. If you're pigeon-toed, you're kind of pushing slightly inwards. And what happens when the bridge was wobbling, people's feet were getting further and further apart, and so the combined forces pushing out were getting bigger and bigger. And so eventually all the people were literally pushing the bridge from side to side. It's called asynchronous lateral excitation. But the thing that was kind of interesting there was they're saying, can you create some sensors that will sense the footfall? And so this was actually the first wireless sensor network that we created, this first Internet of Things object, where the things were people's feet walking across the bridge. And I didn't realise it at the time, but this was kind of this kind of work that I was then going to do for the next 10-15 years, putting instrumentation onto people in the city to understand the performance and how they were behaving. The sad thing with this, though, was that as soon as all that experimentation had finished and these 2,000 people had walked across, we stripped out all the instrumentation. So we're not measuring at all how this bridge performs. And I was kind of always quite sad about that, because I thought it would have been really nice to actually constantly monitor this bridge to see how much it's moving and see how it's feeling. Is it feeling under strain or stress? But also, they ended up putting dampers on to stop it wobbling, just like on the car shock absorbers. And again, they just put in static dampers. It would have been really cool if they'd put in dynamic ones, so that every Friday you could just turn them off and let the bridge wobble. But unfortunately, there's often political reasons as to why those kind of things don't happen. So the other kind of, I guess, focus of the research has been very much around this observation that within the built environment, there's an awful lot of work that goes on around modelling and simulating the way that the actual environment is created. But my observation at 12 years at Arup was that there wasn't that much time spent on looking at the operation of the built environment and how it actually performed. So we do this massive investigation as to how we think it would work. We'd then build it, and then typically we'd go on to the next project. And to me, there's just there's an important missing piece there, which is trying to understand kind of what this kind of post-occupancy performance is, and so that's kind of driven a lot of the work, which is around this idea of data then becoming a material that you can work with, that you can manipulate, but then also this notion of kind of how that data is socialized is the processes around how that data is used. And if you just look at the way that the internet and social media has changed the dynamics of the way things work, I think there's things that we could learn and apply in this kind of domain. So, for example, in the industrial era, you could see physical production, you could see physical activity. Whereas if I was to walk into any of your offices at any point in the day, I would see people sitting there behind computers. Are you doing any work? Or are you just sitting there with your hands on the keyboard pretending to work? And that physical representation of output in the knowledge era is very, very different. Does that matter? I don't know, but it's an interesting thing to think about in terms of what these data shadows might tell us about the world that we live in. Okay, so how does that relate to Intel? Well, so Intel, in case you don't know, make computer chips. Intel basically bought a farm in Silicon Valley. It wasn't called that at the time, but they bought a farm just outside Santa Clara, and that's where they started to make the kind of semiconductors, and they kind of created Silicon Valley. So they are kind of the forefathers of that. They have a massive monopoly on things like the server market. 85% of all servers have got Intel architecture inside. So this whole world of kind of big data and cloud, cloud is very good for Intel because there's lots of these devices being produced. But they're less well known for the moving down into kind of the mobile end, the smaller sort of lower power devices, where people like ARM have a kind of a stronghold. But they have this vision of trying to create energy efficient performance in terms of the computing, so they're continually trying to drive down the power requirements of these chips. This notion of security and actually being able to get kind of end-to-end security of data is also a critical thing for them. They bought McAfee a couple of years ago, and the intent there was to be able to, rather than having software controlling security, actually building that into the hardware of the actual technologies, and then connectivity as well. Obviously, everything now, every computing node invariably is being connected to the network in some kind of way. So those are the kind of the three pillars of the work that they're doing. And but I think what's interesting once you kind of sort of look behind the curtain within the company is that they've had a strong influence around experience design that's been growing since about the mid-90s. In the mid-90s, when the PCs really started to sell more, they started to understand they were having to sell computers to people who were going to use them in a more kind of social, familial kind of way, as in computers going into the home. And the way that they were being sold was actually they were being sold for geeks, basically. And so the whole kind of model where they were pitching wasn't really working. So usability became an issue. People weren't prepared to go through a whole admin screen to be able to use a video camera or a webcam, for example. So they've had this strong kind of focus on trying to understand what the user experience should be and designing the experience of those computing platforms to cater for that. So as well as just kind of building these chips, they're also very much interested in trying to create the ecosystems around them that will allow those chips to be sold. So what that means, kind of in a kind of city context, everyone now is talking about big data. This is just a reality of the world that we now work in. Everything has the potential to be streaming massive amounts of data anywhere. And that massive amount of data anywhere has the potential to be able to do anything in terms of providing services to us. The reality of where we are in terms of technically being able to do that, all the different bits are there, but this is a very, very emergent market. But if you think about this in the city context, these are all, if you're working within a city's environment, you kind of know that these are all the sort of the macro trends that are occurring, which means that, companies like the Intels want to understand what their role might be in this kind of marketplace. So if I think about kind of why, why they've set up an institute in London with UCL and Imperial, it's largely because there isn't any Intel labs here. They're over in Dublin, so they've actually set up the labs over here in London. Largely because there's a massive amount of investment coming into London at the moment. So there's the Future Cities catapult, seeing 150 million investment over 5 years. You've got the work of the GLA. There's a massive amount of support and focus on London trying to be kind of an exemplar city of things happening at scale. So that's why we've actually started to invest here. The institute itself has been, so this is the goal. So we're looking at exploring how technology can enhance quality of life, create new economic opportunities, and improve environmental well-being of cities. So this is the triple bottom line sort of view of the world: economics, environment, and kind of the social aspects of the work. The way that we actually, if you like, differentiate ourselves from other research institutes around the kind of cities area is that we have these three sort of guiding principles that kind of help steer us through our course. One is that we're trying to design for humans. There is that. If you come back to the Intel's experience design or experience-led approach, fundamentally cities are people. It's not physical infrastructure and the things around it, it's the people in those systems. The building for the long term is, again, we've seen lots of examples of where temporary installations or pilots have worked for a short period of time, but it's actually been the longevity of those that's been the real issue. So we're looking at systems that we're deploying for sort of 2 to 3 years, as opposed to 2 weeks to a month sort of duration. And the triple bottom line, which we've already mentioned, the socio-economic and environmental sides. And I guess so. This is the website where there's lots of this information that I'm talking about now is basically up there. So cities.io, in case you can't read it. The institute itself is set up. There's these are the kinds of some of the principal researchers within the group. So you can see on the left side is the Intel team. David was here earlier on. He's just unfortunately left to fly back to Dublin. He's based out of Dublin, out of Intel Labs there. He is an anthropologist by training. My background, so I'm the other co-PI at Intel, and I'm based here permanently. My background is in engineering and artificial intelligence. And then we've got a managing sponsor who is based out of Intel Labs Europe, and so Charlie's the guy that kind of put together this idea originally, and he's the one that provides the link back through to the Intel business. And Rajiv is part of the University Collaboration Office, so he maintains the linkages between the different what Intel call collaborative research institutes, which are their outreach program with the universities. On the right hand side you can see we've got the UCL and Imperial Links. So at the UCL side we're actually funding researchers over in computer science with Professor Yvonne Rogers, and Lisha has also been, she's the deputy PI on the programme, and we have 7 I think PhDs there and 3 postdocs at the moment, and they're typically focusing on so computer science, but they're again interested in how people use these technologies, so the interactions that people have with them. So it's a bunch of, there are some computer scientists, but there are also architects, social scientists, so people who are interested in how these technologies might get used in a living context. And then at the Imperial side, Julie is it's again computer science, but they're at the other end of the computer science spectrum, so to speak. They're very much interested in the kind of wireless sensor networks, the low-level routing protocols, the technologies that will allow this networked infrastructure to exist. And if you like, I guess where all of those people come together is in trying to integrate around projects, actually deploying real living things out in the field. We have kind of three focus areas. One is around these what the EU is starting to call cyber physical systems. So this is the Internet of Things, ubiquitous computing, sensor networks. It's all kind of the same kinds of technologies. We're also interested in this notion of directed crowdsourcing. So Licia is very much interested in how you can use kind of social media to be able to understand the behavioural patterns of people in space. And then Yvonne has always been working in this area of kind of a science of behaviour change. So we're looking at how we can actually nudge behaviours, and I'll come on to that in a little bit. We have 13 PhDs and RAs across the board. They've all got project pages up on the website, so you can go and see what their individual elements of research are. But I'll kind of skip that for now. I'll pull on a couple of them a bit later. The approach that we take, this kind of comes through some of the work. This is also kind of the way that Intel works in many of its product groups. But we have a real there's a real mix of people within the team at the moment. All of those disciplines are covered, plus more. The typical approach that we have is that we have basic research questions that we're asking, but we also do a lot of kind of field study where we go out and watch and observe how those questions relate in the real world. And so a lot of the work is based around observation. But we then go through this kind of iterating design process where we are prototyping these different devices, putting them out into the field, observing them again, and watching how they develop. And this is the kind of the in the wild and the field deployments. And so it is a very iterative process. We're continually trying to create the minimum viable product that we can go and get out there and actually test out in the field. That's the approach that we're trying to take to this. So what that means is that we're trying to build stuff and deploy it. In terms of kind of who we're working with, so we started last year, so we've been running since October 2012. And the head of Intel Labs, one of the things so he's a big open innovation fan, and so he's doing some great work around setting up different collaborations with different institutions around Europe. He hosts an open innovation conference in Ireland, and he has this thing called Quadruple Helix. Quadruple Helix Innovation. What does he call it? Sorry, Greg and Hannah just walked in at the back, who are both in the Intel team. What does Martin call this? It's Quadruple Helix Innovation. I can't remember these kind of things because they confuse me slightly. But what he's basically saying is it's the interweaving of not just industry and academia, but also government and citizens as well. And so it's this idea that all of these different stakeholders all have a key part to play. With projects like cities projects, we have to engage all of these people, and so we deliberately kind of call out that that's what we're trying to do. And these are just a bunch of the people that we're actually working with at the moment on various different projects. So hopefully you've had a time to scan some of those. Okay, we're halfway. So the kind of projects that we're doing then, these are the four main sort of themes of work that we're doing. We have this overarching kind of project called City as Platform. I could have also put up a slide here which shows within cities you have all these vertical different sectors, so energy, transport, healthcare, and all those kind of things. What we're doing is we're saying that yes, all of those things we need to be working across and looking at the different ways that we can do that. So the City as Platform is a way of saying this is some of the technical layer that we need to put in place to allow us to do some of the activities that we're talking about. I'll come back to that with some specific examples in a minute. The other three kind of areas of focus of the researchers is around this notion of harnessing the invisible city. And when I talk about this, I would like to give sort of two extreme examples. So one is, yes, we can look at the different interfaces that we can create to flows of information around the city, and we've probably all seen lovely visualizations of data flowing around of, say, mobility, so transport through a city, or the energy grid within the city, and understanding how all those flows interact. But it's also some of the other invisible things that we don't necessarily see at first glance, which is the number of people who are caring for the aged within communities, and that's not paid work, it's just work that they're volunteering to do, and typically that isn't recorded anywhere. Now, as the city population is aging, there's one of the worries of the NHS is that actually the cohort of people to come and provide that free invisible service might start to disappear, or it might be being drawn down. Now that could have a massive impact on a city that then has to start to care for people that it wasn't expecting to care for, because suddenly they become visible within this system. So we're actually looking at the kind of, right across that spectrum of trying to unsurface what some of these invisible elements of the city might be that would help decision makers to understand where they could intervene productively. And there's also an element there of the interfaces as to how you can support that decision-making processing. So one of the postdocs at UCL does lots of work on multiple people making decisions around multiple displays and how you can support those kinds of interactions. Whereas typically with this kind of device, it's typically a one-on-one interaction. The enabling connected communities, this one is a bunch of research kind of framed around this notion that we aren't looking at cities from a top-down perspective. Cities are collections of people in communities, in neighbourhoods, and those communities might be physically located, or they might come together once a week in a particular location, or they might be virtually spread across the city. And it's looking at the different ways in which we can start to understand how you can support those connected activities. And then the sustainable practices, this one is around this notion of trying to nudge people's behaviours in certain directions. And there's several members of the group who have done things like looking at energy monitoring in homes, for example. So I've done it more at an office building level than a home level, but my observations within commercial buildings, for example, we tried to put green screens up in the foyers of buildings to nudge people's behaviour to use less energy. Now, unfortunately, over my 5 years of work in that area, I never found a way to be able to lower a building's energy use by displaying the energy use of that building in the building. That's kind of quite annoying in some ways that I could spend 5 years not being able to do that. Maybe I just got it wrong, but I suspect that actually there's something challenging about actually creating these sustainable practices that do last over the long term. I think it's a very hard problem to solve. So again, there's on the website, all the different individual sort of PhD projects are up there, and also we're slowly adding in project pages for the other activities that we're doing. So again, you can skim through those if you wanted to find out more about the individual activities that we're doing. But for example, just to pick out a couple, one of the projects that we have from the technical end is looking at this notion of data muling. So when there's these 50 billion devices connected to the network that Cisco talks about, the actual physical communications of connecting those devices is going to be a massive challenge. Is there enough radio spectrum for those things to be connected? So we have this notion of data muling where you're probably all carrying around a host device, a mobile phone in your pocket. Intel makes reference designs for these mobile platforms. There's no reason why you couldn't actually have running in the background a service that basically, whenever it goes near to something else that provides information at the same service, it could piggyback data through here, through low power Bluetooth, for example. So suddenly you have different ways of being able to exchange data around networks. So these could then potentially become a data mule, that the more you move around sensors, you could basically be generating revenue, microtransactions, by basically carrying other people's information for them, but at no real cost to yourself, if you can start to manage things like the battery life and that kind of thing. Okay, I'll keep going. Okay, so where we as Intel are focusing is we are looking at developing this end-to-end platform that will support. This is the City as platform piece, which will allow us to, if you like, service all of these different research projects, but also from an Intel kind of commercial perspective, this is where the future of their technologies might lie, in providing some of this end-to-end infrastructure. So we have at this level, kind of, if you look at the bit over to the left, yes, at the lowest level there is this notion of sensors and sensing devices and the different chips that are required to kind of provide that core technology. But there's also all of this other data management, the connectivity, the intelligent algorithms around this, the provisioning of the security around this. These are all other parts of the Intel business that there's people working on to provide those services. And then you've also got this level at the top, which is around the different service models that could come from that. So far there isn't actually a model of how you provide these services into, say, government, and so this is a real area where people are trying to understand how that's going to play out. So what we're doing is we're building within London this notion of a living lab where everything is deployed out in the field. We're testing these ideas of things like manageability. So if there are 50 billion of these devices out there, you can't have a man in a white van going around to make sure, to fix them. So we have to understand how you can basically log into these things remotely and update them. Reliability, obviously we need to be able to create an infrastructure that just keeps running 24/7. You can't get the Windows blue screen of death. So we're using platforms like the Wind River Linux, which is on the Mars rover, for example. So industrial strength operating systems that, in theory, don't fall over, or you don't want to fall over. It's a long way to go and fix the Mars rover, for example. And then trustworthiness is this notion of if you have sensors out in the field. So say if within Hyde Park area you've got 100 temperature sensors, how can you trust that the data that they're transmitting is accurate? Now, if you look at an individual node by itself, it's really hard to understand if you rely on that value. However, if you can start to benefit from the fact that there's 100 sensors measuring temperature in a local area, you could start to look at the relationships between each of them to understand, is that thing probably giving me the right information? So there's different models of kind of trustworthiness that are being explored there to understand if you can actually, trust what's coming through the network. And the last one, interoperability. This is, again, a massive focus. There's lots of examples of these networks that exist in isolation. It's proving to be very difficult to get people to work across those systems. So we're doing one project, the schools project, which is, which I'll come back to, which is a key part of that is exploring how data that we create in that can be used by other people that we don't know about yet, in a way that they might want to use. And so this notion of kind of open data and sharing data, I think is pretty critical. And if anyone in the room has been trying to use data from different data sources, whether it be energy data from a government website, or whether it being live energy data from metered data, it's quite tricky to do this interoperability piece. So in terms of what we're deploying, there's 4 key projects. We've got a large heterogeneous sensor network in Hyde Park where we're measuring ecology, air quality, water quality, noise and light pollution, but also doing some of the kind of more qualitative sensing as well in the park. So trying to understand people's mood or feelings or comments about the park, or looking at how the staff, what's happening in from an events perspective. From over in Enfield, again doing a similar project but focused around air quality monitoring. So they've got an air quality plan that they're implementing at the moment, investing a few million over the next 2 to 3 years, trying to improve air quality in the borough. We're interested in helping to monitor air quality levels, but also try to understand how you can then influence and improve the lot. And then Brixton Listening Lab, again looking at the behaviour of people within a local environment and seeing how we can nudge behaviours. And then the schools project, which I'll come back to. So in Hyde Park, we're looking at basically putting a whole different series of these sensing nodes out there. So we're exploring at 2 levels. One's the data level, so we are interested in the data that comes out of all these instruments, and so there's people that are using that as the basis for their research. But we've also got a bunch of researchers who are looking at how you get that data. And so they're looking at the different routing protocols, the different, how we can, reduce the energy requirements, how we can do energy harvesting, the different communication models, so GSM, low power Bluetooth, TV white space, all the different kind of models of communicating across the park. And doing it in the park to understand how in situ that kind of affects what gets used.
Fixed nodes powered by a battery?
So the majority of these that are shown here are fixed nodes. The majority of these ones will actually be powered from the mains. There are also some battery-powered sub-networks. So all of these are based on what we call gateways. And so Intel has a gateway device that we're using in the park at the moment. Off that will hang low power stuff, but we've got a few drone experiments as well that'll hopefully go into the park, but they'll always be temporary as opposed to permanent, because for some reason they won't let us just fly drones around the park permanently. But with the water quality, for example, we're looking at we've got a duck drone that basically goes around collecting water samples within the Serpentine, which actually might be a way that we do long term get a drone in the park, because it's quite innocuous it being in the actual water. It doesn't interfere with too many people. Whereas having a quadricopter flying around, probably people will complain at that. Don't know why. The Enfield example, this is, so we're in discussions with them at the moment, but at the moment they get, there's 100 air quality monitors across London, the London array, that report back to Brussels, and you will basically get a fine if we go over, or we don't hear anything if there's nothing, if it's within parameters. There's 3 air quality monitors in Enfield, so across the borough here. From those 3 air quality sensors, they're creating this heat map of air quality across the park in real time. Now, scientifically, what I would say is that yes, there's a model that drives that visualization, and you can see how it's influenced by things that look like roads. That's the North Circular, the M25, and the A10 going through. So one of the things that we're trying to challenge is, does that model based around vehicles being the emitters of particulates, is that a valid model of air quality across the neighbourhood? So we want to put out 100 air quality sensors across the neighbourhood to see if their results change our perception of that map. Okay. The other, that's the Living Labs London projects. The other sort of set of projects that we're doing is around an Internet of School things, where we're trying to put these connected devices into schools. Now this one came, the seed of this was sown about 5 years ago when we were doing some work in schools with key stage 3 and 4, so 11 to 16-year-olds. And our task there was to look at how you could improve the science classrooms, labs, to try and encourage more kids to do science. Science, technology, engineering and maths. It was all STEM subjects. And through that we observed that actually the way that kids are using technology is actually very limited, and lots of that technology was bought but it was just sitting in cupboards not being used. And it's because they were using data loggers and things that were actually kind of quite horrible to use. And so they'd spend a massive portion of the lesson getting these data logging bits of equipment out of the cupboard, setting them up, putting them out, measuring something, bringing them back in, downloading the data, uploading it to an app, graphing it, and then starting to do the lesson. Because that's when they start to get to the data that it was something that had been recorded. And that could often be sort of 40 minutes into the lesson, which just seems a kind of an odd waste of time. So we were trying to flip that around so that you would get a device, you would turn it on, it would start recording whatever, temperature, humidity, whatever it was that you were measuring. You'd go to a web page and you'd open up a URL and you would see the data coming live. So within 5 minutes of the lesson, you're basically starting to explore data. And so that was kind of the premise of the project. We're trying to make it very easy for children to be able to work with data as a material. But it's also this notion of long data. Again, talking to some of the kids, we were trying to explore this notion of what they'd want to record. And some of them were amazed that the new school that was being built was only designed to last for 60 years. Now 60 years is actually kind of quite a long lifetime for a building. Most buildings are designed for about a 25-year lifetime at the moment. So even kind of our best case, they were thinking, oh, that's very short, because they see buildings around that have been here for a long, long time. And so we started to explore this notion of how do you what could we put into the school that would reflect that school aging over a 60-year period. And so they had a simple thing where they wanted to capture annual events. So there was data streams that were also one event per year. So suddenly you've got a very slow data stream that requires many, many years to develop. And that could be, for example, the day of the year that the cherry tree blossoms in the front of the school. Now imagine if you had that data point for the previous 60 years of the school, and how you can then use that to understand things like the changing climate locally, for example. So there's kind of notion of that sort of data as a material, it being long data, but then also the fact that schools are typically hubs or centres of communities. What can be created in that local context that can be shared for that community's benefit? So we are we're pursuing this project at the moment. We're about halfway through. Han and Greg are heads down trying to get stuff deployed into schools over this next bit of half term, where we're testing all the first devices going out. The basic setup that we've got with the 8 partners that are working on this is we have a bunch of sensors that are measuring stuff. We have a platform using Xively or COSM or Patch Bay, for those who've used that in the past, which is where the data is being stored. But we have this wrapper around it, which are the services that the schools actually interact with. So we're creating kind of portals into that data that allow teachers to create observation kits to construct lesson plans. But then also there's these kind of different actuators that come out of it, which it could be dashboards, it could be data that shows information coming out. But it's also kind of some of the more kind of intangible things like the lesson plans that allow teachers to actually use these bits of kit within the schools. But it also allows us to look at to look at this being a data set for the school to use, but also for the greater school community to also be using. So, for example, we're measuring the energy use of each of these schools. Now, at the moment, we're doing 8 schools, but you can imagine if that was to scale up to the 24,000 schools in the UK, where they were using these energy monitors to monitor, for their teaching purposes, but as a byproduct, you then also had a network of 24,000 schools, so a building topology, all being measured for energy use. Real-time open data set, would that be useful? I think it would be quite useful to a broader community than just for the school teaching one. And then this kind of interoperability piece is what I was referring to before. There's 7 other projects that are also funded by this same grant, and we've got a shared work package across all 8 projects. And that work package was to define a way that we were all going to share data across each of the projects. So we've defined a way that we can catalogue the data so that I can go to any of the other 7 projects and go to a URL and say, tell me what information your system is making available. And that could be, so it's open in the sense that there's a clear way to be able to read that data. Open doesn't mean it's free to use in that sense, in that some of the projects, so City Airport is one of the other projects where they're providing a whole lot of services around City Airport. Most of their stuff is all locked down because they want it to be paid for services. So there's always a kind of a payment transaction model for their data. The nature of ours, because it's educational and for schools, typically we're at the other end of the spectrum where all of our data is pretty much open. In fact, at the moment we don't have any data sets that are actually closed, I don't believe. And the kind of things that we're focusing on is so weather, mobility, energy and health were the focus areas that we kind of went into the project with. But the first phase over the last summer term was working with the school kids and teachers to try and understand what the first use cases were, the first bits of kit should be that we built. And so performance and robotics have also been added into there. For example, on the robotics one, the kids wanted to design a robot tug of war. And this came about from originally they wanted to have a tug of war, so a rope that's fixed to a wall basically, that they could have a tug of war with another school somewhere else. And that could be an asynchronous competition. It doesn't need to be at the same time. It could be, but equally you could be competing against another class doing it a week before or a year before, or even they could compete against themselves a year before when they were in a younger year group. And having this kind of idea of a national league of tug of war from for schools. Okay, so just to finish on then, so there's actually no, sorry, on that. So we've got a whole bunch of, we've got 11 use cases now that we're deploying out in schools. Is that right, Han? Or was it 14? It's 11 or 14? 11. So we've got 11 things that we're testing with schools at the moment, where we're actually deploying, giving them kit and lesson plans and seeing how they actually use those materials. Okay, so final observation is that so in all of these things there is this real kind of socio-economic and political mix to what we're doing. So with the schools project, actually there's an awful lot of time was spent there around the interoperability aspect and how do you make this data accessible, for other projects. And this one is kind of, and this one of the other projects is working on, it's working with Westminster Council. This is one of the other 7 projects, and they were talking about they're trying to aggregate data sets around parking. Now, I've been unfortunately I ride a motorbike, and so because I ride a motorbike in London, I occasionally park in Westminster and forget that they're the only borough that charge to park, so I get a parking ticket. So I get fined quite heavily for parking in Westminster. So I understand kind of that Westminster generates an awful lot of revenue from parking fines. Now, you could argue that from Westminster's perspective, their motivation for charging for parking is to try and make it easier for people to park and to reduce congestion by stopping people having to drive around and to find a place to park as quickly as possible. However, you can imagine that if you were to say to them, okay, we need to create this interoperable system whereby a person wanting to park should be able to query both the Westminster's parking providers, but also any individual who's maybe got using the the Park on My Drive website, which is kind of where peer-to-peer lending of spaces, or it could be the NCP, another provider of car parking spaces. Imagine if there's a platform that allowed you to just go and query all of those to find the nearest parking places. Now, I'd argue that Westminster Council should be motivated to do that, but actually they're kind of not, because if they do that, they're going to potentially erode some of their revenues from providing parking services. So you've got this really interesting, technically it's possible, but politically, I'm not sure if these things work. So trying to understand how to create some of these kind of sustainable systems of systems, I think, is a really interesting kind of common theme across what we're doing. Okay, so just to end on then, so this is, so I guess the reason for coming and chatting to you guys is to give some insights to some of the things that we're doing, but it's also to try and hopefully, this for me will only be successful if one or two of us get together afterwards and actually start to inquire about a potential thing that we can do together based upon some of these things. So I've got some ideas down here. We've got, we're always being asked for kind of what's the war chest of city problems that need to be solved. If I had a grant for every time someone asked me that question, would be sorted. So I think that actually sort of surfacing out sort of real problems is actually incredibly difficult. So please do come and speak to me if you are aware of those. But I think also we are deploying this stuff out in the city. So if there's things that you are sitting here going, oh, I wish this was sensed, I wish we had this data stream for London, then again, please come and talk to us, because we've got people at the moment who are wanting to try and support those data streams. And we've got a narrow window of opportunity to try and help to support to actually get those things done. And then I guess, the end one is that, the future city business models, this is one that I think that we don't do enough work on at the moment. And it's going to become more important for us over the next year or so, which is, I mentioned with the schools idea, this notion of people creating data that other people could use. Kind of what are some of the things like the microtransactions that could take place that would allow us to charge for those things differently? Are we always going to expect schools to just buy the sensors and then host all the data? Or is there a different model for how they could actually buy into those services? And I'm obviously saying that because I believe there are other models that we need to look at in terms of how we actually set up these systems of systems. And that's me. Thank you. Any questions? Yes.
What are you doing in Brixton?
Brixton.
Yeah.
Han, do you want to describe what's happening in Brixton? Because that's Han's project. Perfect.
Okay, it's inspired by nudge behavior models around air quality. And a lot of times with air quality, London is, sorry, did you guys get the brief on air quality yet? London is one of the worst cities for air quality in Europe. And out of London, there's two boroughs that are particularly bad, and one of those happens to be Lambeth. And then so, it's very interesting when you think about things as part of your community, but of course the environment is part of your community too. So we want to be able to give citizens a more tangible way to actually interact with something as amorphous as air quality. And so we're working with stakeholders, citizen groups, from government to activist groups, to sort of imagine if we had a square mile test bed, right, where we could get them to do one change in behavior. Currently what that is that it's tied to another statistic. Generally for London, I think 20% of all car journeys are actually a fraction of a mile or less. I think it might be 25
a quarter of a mile.
And then so we have to identify how much of that is relevant to Brixton. Part of that will be relevant to Brixton, right? And then so that probably means that some of those journeys maybe can be encouraged to be walked. And then if we do that over a long period of time, at scale, what effect could that have in terms of air quality? We know that air quality has a lot of different factors, right? A lot of that might be through traffic, but I think it's really important that we empower communities to be able to take some action that is relevant to their communities. What this also helps us actually understand from an urban planning viewpoint is there's a lot of different reasons why people choose to walk or not walk, right? So one of those things could be very simply the condition of the road surfaces, right? Other things can be lack of or over provision of public transportation needs. It can also tie into feelings of safety, examples of crime. And so what we actually see is one small intervention. In this case, it's a technological intervention that we're actually working in terms of a participatory design model, can actually use as an urban planning tool to be informed not just policy planners and the borough government, but also people down the ground in terms of that bottoms up, to be able to think about how they can work more collectively together to imagine the future of Brixton, at least in this area. Hopefully that makes sense.
Yeah. And I think that was kind of one of the interesting things there in Brixton, was that how that project started was, so do you know Brixton? Do you live in the Brixton area? You live in Brixton.
Okay.
So we got contacted by Brixton Green. Brixton Green, I want to know the word. Is it? Actually, so it's one of the stakeholders. This is Brad, and I've forgotten his surname, who's doing the development of the land adjacent to the railway that basically splits Brixton in half, and they're doing all of that cooperative redevelopment there. And what they were basically saying was, we think there's a role for technology to play in this development, but we're actually not quite sure what that might be. So we started it with a very open proposition there around kind of how we might get engaged, and it's now wove its way into this project that Hannah's describing, which hopefully starting now. So it's kind of hopefully starting this month, next month.
Continue our meetings in
Yeah.
December, and then really start the planning phase, starting
And implementation.
There's
Yeah.
a lot of room for participation in that, because it's just, I think our grant is to actually do that participatory design, which is really actually quite wonderful, to imagine how we can collectively design this intervention with the citizens and learn what that can actually teach, not only teach us, but also the different groups that we'd like to work with. So this, I think, is really great because it gives us this room to really take a bottoms-up approach for this project.
Any others? Yes.
I've done quite a lot of air pollution monitoring over the years, and certainly just doing some in the 90s, was putting lots of monitors around, so I know quite a lot of the issues around this.
Yes.
So I'm quite interested in this, and I've seen Intel now and again kind of come in and try and, from my point of view, work out how they can sell more tech to solve a problem, or to find a problem that their technology solution is the answer to. And they were, a few years ago, they were trying to wire up a whole city. And I hadn't ever heard whether it happened or not. And
Yes.
they were looking at something in Portugal for a while, and there was
Yeah.
somewhere else. What the point is, this is Intel trying to sell things, and you're being quite open about how open data and social networks are important, and they're generally all free.
Mm-hmm.
And Intel isn't going to make money from free stuff,
Yeah.
or is it?
So this is what I think is really interesting for Intel, and this is kind of one of the challenges that they've got, because the model of selling computing technology has changed since over this even this the past decade even. There's quite a few different questions there. So in terms of the kind of the first bit around air quality monitoring, it's quite amusing that everybody we go to speak to and say, should we do some air quality monitoring? They say, yes, please. And we know that we can. So we know that we can measure it. I would also argue that there's a massive range of sensors. So what you're actually measuring is massive. Is very, very varied. So whether it be at the air quality end of the spectrum, which is kind of a £20 piece of kit that isn't really measuring air quality. It's measuring air quality in a very liberal sense of what air quality actually is. However, and then you've got the other end of the spectrum, the London Array, which is very scientific, very expensive equipment. The reason why we've only got 100, even though 100 is actually quite a large number of them, is because they're just so expensive. So we couldn't have more of those. Where is the middle ground in that? Can we put out so there are technical challenges around, can we put out an array of 100 devices that calibrate against those 3 devices and therefore measure in a way that's good enough for us to trust that they're useful sensors? So there are still, and I don't believe those technical challenges have actually been solved yet, even though we've been trying to do this for a long time. But then with that, because I'm talking about the kind of the £50, £100 cost of particulate sensors. So it is the low end of them. But I think there's actually a more important question though, which is the one that we're actually struggling with at the moment with Enfield, which is, if we could give you a measure of air quality, what would you do differently with that information? So what interventions will you go and take? Because we need that to try and design where we put in these air quality sensors. So they do have a massive tree planting scheme program up there, and they're planting lots of trees in the urban landscape, which is great. If we were to then measure before and after air quality levels where those trees are being planted, you've got issues around kind of, well, what size and age do those trees need to be optimally trying to have any beneficial impact. But then also you could say, well, actually, if we then go and do some qualitative surveying and say to the residents of that street, how do you feel air quality has improved? Intuitively you kind of think, well, they probably will think it's improved because it's a nicer space to be in. And so then you get these really kind of interesting questions around what are you actually trying to measure, and for what purposes, and what actions can you take? And that to me is actually where the room goes very quiet when you start to ask some of those questions. And that's where the interesting bit of air quality monitoring is for me. On the question about the selling chips and making money and openness. So this is one of the gateway devices. So this is and I brought it here just so that people can have a look at it if they are so inclined. This is a kind of, do people know the Arduino platform? It's what lots of hackers and makers use. So this is basically a small computer. This is the Quark chip, which is the kind of the new Intel sort of low power sort of cheap chip. But this board is about £40 to buy now. And it's a Linux machine, so it's a full PC, and it's got different connectors and all that kind of stuff. Do we make lots of money out of selling these? No, the margins are probably quite small on these devices as compared to servers and PCs, less so notebooks, less so phones, as you get down the value chain, it just get harder and harder margin-wise. So the interesting question here is that end-to-end sort of platform. Do we, and the reason why that platform might be open to store data is because of the other services that you could sell around it. Now at the moment, if you spoke to different people in Intel, they probably would say there's no way we can provide an open data platform for people to use. That doesn't make economic sense. Equally, I could argue, well, if you don't, then you're going to miss out on so many commercial opportunities, because that's where we've always benefited from putting intelligence into ecosystems. So therefore, the ecosystems are now changing, and we need to adapt with that as well. But we haven't got the answers to those things yet. So we have the benefit of being in an institute where we have open IP. So our natural status quo is for everything to be open. And so I've always got the argument of, we have to make our data open because that's part of the institute's remit, is to make all our stuff open. And our two projects at the moment are government funded, so they've also got to provide all open data because they're publicly funded and it's part of their requirements on that particular call, like the school ones, for example. So I do have that luxury of being able to actually practice that. But it's a very real problem. There's obviously people in Intel who are saying, how do we commercialise this?
Great. Any other questions?
Yep.
Let's do like one last one, Jonathan, and then we're going to bring this off.
Yeah, sure, I'll be around in a sec.
I think to bring up, when you start collecting this much information, and a lot of it is about what people are doing day to day, you run into people's privacy concerns. I was just wondering how you address that when you're doing these projects.
Yeah, so we're managing to sidestep that issue in a very practical way at the moment. We're not allowed to store personal data, just from an institute's perspective. So that's kind of one of the default stances that we have. It just makes our life so much more difficult. If we are doing individual researchers have done projects where they have been interacting with individuals, and so they've gone through the ethics committee to actually get their particular projects approved in that sense. But all the things that I've been talking about, the projects here from the Intel Institute side, we just don't store any personalised data. So on the school stuff, there's no pupil information at all stored. There are various so the closest we have there is that we have an activity monitor where kids can wear a device for the course of a PE lesson to then compare themselves to the other 29 kids. but that's not stored, so only they know that ID. So we don't know who in the class is who, and so if the kid forgets which one they were, then they forget that they don't know which one they are. And then the other one is in Hyde Park. We are working with one of the telecoms companies who are giving us phone data so we can understand the pattern of movement of phones through the park, which are obviously then a proxy for people moving around the park. You know, they're being very clear about us not being able to get any demographic data from that. But we're actually saying that's actually fine. We actually don't want, you know, we want demographic information at the level of, for this hour on this day, you know, 52% of the people were in the age bracket X to Y. That's interesting, but we don't need to know anything about individuals. And all of that anonymized data is only carried from is not carried between days. So if your phone goes in on a Monday, we don't know that phone X on Tuesday is the same as phone Y on the Monday. So we don't have any way of being able to track that. So it's all anonymised at source, is the short answer.
Great. Thanks very much, Duncan. It's very much appreciated.
That's okay.
Do you keep everything up to date on your website and stuff about how the
Yes.
developing and everything,
Yeah.
so we can all watch from there as well as
Yes, yeah, so subscribe to it, and we tend to try and tweet whenever there's an update to projects or people, for example. So.
Great. Thanks a lot, Duncan, for coming.
Okay,
in.
no problem.
Drinks next door with people, like meeting everyone from other people from Intel as well.
Okay,
Right,
cheers,
thanks
thank you.
very much.
Thank you.